Good day.
Hello, hello, everyone. Giving some people some time to come in. I hope everyone's having an awesome Thursday so far.
If not, at least an acceptable Thursday.
Yeah, right. So without further ado, aloha mai kako and welcome everyone to NDPTC's November 3rd Thursday webinar. Mahalo for joining us as we continue our monthly conversations on emerging hazards and community preparedness. Before we begin, just a few quick reminders. Today's session is being recorded and it will be uploaded to both our NDPTC YouTube channel and our Facebook page. So please feel free to place any questions or comments in the chat throughout the presentation. To help keep things running smoothly, we ask that you refrain from interrupting Jeff while he's speaking, as we'll set aside time at the end of the presentation to address your questions. So today's focus is extreme heat. Together, we'll explore some guiding questions. What is extreme heat and why does it matter? What makes it extreme and how does it differ from most other hazards? With that being said, we're honored to welcome Jeff Rubin. He has served as the emergency manager for Oregon's largest fire district and has led major projects in hazards and health preparedness at the local, state, and national levels. He is a fellow of the Geological Society of America, has presented internationally, published widely, and teaches in the Oregon Tech OHSU EMS department. We're also proud to say that he is one of our wonderful NDPTC instructors. So we're grateful to have him with us today to offer insight and context on this important topic. So please join me virtually in welcoming Jeff Rubin.
Thank you. And just to clarify, that is past tense as emergency manager of our largest fire district. I am going to greet you all by giving you a poll. You can pick off as many of these as apply to you. Just kind of curious who got out there in terms of what your experience is with extreme heat. So knock yourselves out. Um, Once we get through this, I'll toss up another one just to see where we are, and then I'll have one more during the day. I'll probably say this more than once just because we have other people joining as we go through, but there will be, I have a bunch of references in the slides, and for several of those, there will be QR codes if you want to shoot them, but there'll be a PDF that I'll drop in the chat and then we can send out afterwards if you want that have all of the anything that's linked in the slides will be in that PDF, so don't worry about trying to chase it down. Okay, looks like things have slowed down in the poll, so we'll see what we have. Some of you all done. I've got a few of you community vulnerability risk assessment. About let's see, we got about 30 or so, and about a quarter of you have been involved in an extreme heat plan. A few of you have respond. Pretty good mix. Workplace training or education, public training or education. Yeah, just kind of curious what kind of experience y'all have, and also just curious what y'all know about what you think about extreme heat. So emphasize this question applies to the U.S. as a whole. And of course, these polls are anonymous. We can see how many are responding, but do not find any individual answers. So don't worry about it. All right. So about a third of you, a little over a third, say heat killed way more than cold. Or if you say heat kills slightly more people, if you say it's the same, one says heat is slightly more, cold is slightly more than heat. We are going to explore that, and I am going to offer my slides at this point. Okay, so as we get going with this, you don't need to do chat intros, but I am curious, for those of you who are attending, where you live and work and what field you work in. Kind of curious what kind of a mix we have here. I recognize several names out there, and I know several of the staff, but if you have any particular interest in extreme heat, let me know. That'd be great. Not Again, just curious. If you do not like your current identity, you can completely make up something new, and that'll be okay too. What we're going to cover today is start with some terminology and evidence base, and going to do a pretty broad net for that. I'm going to spend a little more time than I normally do in a presentation on that first item because I don't want to assume any prior knowledge, and I want to make sure everyone is kind of at the same on the same page for where this is coming from and how we get some of our information. Then I'll start talking about some hazards and vulnerabilities related to extreme heat, looking at across a variety of domains, and finish up with some challenges and planning considerations and take your questions. If you have questions as we go through, so we'll do questions at the end, but you're welcome to drop them in the chat or the Q&A, and we'll get to them. So this question's for you. Why do we care about extreme heat? Why do you care about extreme heat? You can just drop that in the chat. And while I'm waiting for a few items before I give you why I think extreme heat is important, Juan and I just spent the last few days in Oregon. I'm just outside of Portland. Sorry, war-ravaged Portland, I think it's called. Teaching the class used to be known as the Science of Disasters for a bunch of our folks in state. And that was kind of fun. Let's see, health and safety concerns. Dangerous pre-planning. Don't want our responders to have heat stroke. I think it's an excellent goal. Let's do that. Life and infrastructure threats. Urban heat islands. Yeah, so we'll be covering a pretty good portion of that. Here's what I think are some pretty good reasons. For starters, heat kills more people in the U.S. than any other type of weather, and it's not really that close. This has been the case for years and years. It's not something new. So if you're wondering what the answer to that second poll question is, it is this. We are seeing more and more extreme heats, not just in terms of frequency, but in duration and intensity, and we're seeing them in places that never used to have them, which is a particular challenge. Not much acclimation. The places that are not accustomed to extreme heat tend to be a lot more vulnerable to this. And it also just changes what we do and what we need from infrastructure versus how our infrastructure is wired. And I use that term figuratively, not literally. Hello, I suppose it could be both. Okay, so now that we've established it, heat kills more people in the U.S. than any other type of weather. Keep that in mind as we go forward. These are the terms we're going to go over, and I'm going to cover them in more detail. Just wanted to give you a list. And we're going to start out with something that you might think is a little odd, particularly for those of you who are accustomed to the work that NDPTC does and what a lot of people do at U of H. And that is, for years, including one of our former classes, we would spend time on weather the difference between weather and climate. This is actually one of our old slides from that. The weather is what things are in the atmosphere at a set place and time, and the climate is average conditions over a long period of time, and you can decide what that is, a season, a year, or really long term. There are all sorts of weather. Weather is what you're wearing, climate is what's in your closet, weather is your mood, climate's your personality. Weather is what you're having for dinner. I mean, on and on. I don't really care what you use, but the reason I'm bringing this up is over the last year or two, it has become fashionable to start referring to extreme weather events as climate events. And I just want to say that's a really bad idea. We spent 20 plus years trying to reinforce the difference between weather and climate. And we decided now we need to turn attention to what's happening with climate change And, it's basically, it's an ideological use of terminology, and I don't think that's a good idea. So I'm saying that because I want to be really clear what we're talking about. We may see um, increases in certain types of weather due to ongoing environmental changes, but there is still the difference between the two terms has never changed. With that in mind, I want to point you towards a few resources. Some of my slides are from, since I'm in the Willamette Valley in Oregon, these are for our PQR weather forecast office, but pretty much every region has the same thing. And you'll notice we got links here for both the weather and for the Honolulu weather local forecast office. If you're not familiar with these, I strongly recommend them. You can get all sorts of tons of great information. And that includes links to their climate page or pages. So this is the National Weather Service Climate Prediction Center portal. The screenshot is from just a few days ago. So you can see the 14-day temperature and precip outlook, as well as, other updates for what's going on. And you also have links to a bunch of additional really useful climate resources. If you look at what's on the left of the screen, or if you just kind of actually go to that page and scroll down below where the screenshot is. And these are some of the things you can get. You can get uh, all this stuff under climate if you go to the right-handmost column and click on climate resources. And this is the type of stuff that'll come up. So, and there's way more. Again, this is a screenshot, so there's more below where this is cut off. Just wanted to point you in that direction. Pretty useful stuff, regardless of whether you're looking at extreme heat or something else, or just doing some planning, or just curious. Um, I am drawing some of the information from the Fifth National Climate Assessment, which is the most recent. Some of that information has moved off of the website that used to be on and onto a different one. But the link there, we had a lot of flux in federal websites over the last few months. So my links are current as of 2 nights ago. And if you have trouble finding stuff, you can always drop me a line. For those of you not familiar with the National Climate Assessment, or NCAs, they're required by law. It's a congressional mandated report to Congress and the president every 4 years. It has been the nationally accepted assessment of climate change. These are all direct from the definitions. And they break down to regions and sectors for their specific projections and impacts. Another thing I want to point out is it's not just a bunch of folks, in academia or weather service or something else. There's a lot of collaboration among land use owners and operators, infrastructure owners and operators. It's a pretty broad spectrum. I worked with several of the people in Oregon and elsewhere who've been involved in this, and they cast a pretty broad net. I'm showing this slide not so we can talk about the projected variations, but so you can understand that when we talk about changes in, pick whatever you're looking at, precip, temp, whatever, it really depends what you're talking about. You can get essentially little, if any, change in annual precipitation for a specific area, but how and when that falls can be a substantial difference. We may get more or less in the winter, more or less in the summer. Same thing with heat. You may get a change in annual temperature, but you may get not a whole lot in the summer, but huge differences in the winter or vice versa. You may get, maybe it's a little bit cooler in some place in the summer, but it's a lot warmer at night, and we'll talk about why that makes such a difference. There are a bunch of tools if you're interested in how this works. The NCA Atlas, which got moved off of its original host site and is now at the link there, just gives you some tools for how you can access that and how you can play with the data. So just want to make these available to you, and also make sure everyone understands when I say some of the stuff is from NCA 5, or some of this relates to seasonal changes or annual changes. This is what I'm talking about, and how much of that is driven by different scenarios within the National Climate Assessment. So anytime you hear about projected changes as opposed to observed changes, there are a lot of different scenarios in the climate assessment by design, same things that are done internationally. And it's really important to know which model, which model they're using, which scenario. Okay, on to heat. There are a couple different definitions for heat wave. The National Weather Service uses the first one up there. Notice that this is uh, based as much on duration as anything else, and it just says abnormally hot weather for 2 days. It varies by the time of year and location. So um, based on what is normal for that time of year, as in really average over the years and location, what defines a heat wave can change. If it's in the middle of the summer in some places, it probably has to be warmer than if it's in, say, October. And there's no mention in the official Weather Service definition of humidity. So the World Meteorological Office, which has different, broader perspective, they specifically mention local excess heat accumulates over a sequence of unusually hot days and nights. So they include the definition that, yeah, it's not cooling down at night, which is really important. Also varies as can be. Yeah, Michael, there are several different definitions. I probably could take up a few slide pages full of that. Just wanted to show these are some common ones. It's always nice to know what people are using as they go forward. Extreme heat is not the same as a heat wave. You can have a heat wave without having extreme heat. This is straight from the National Weather Service, and this is from their heat safety page. The difference between extreme heat watch and extreme heat warning. And as with most of their watches and warnings, one is it's possible, get ready. The other is take action. But it is worth that these warnings didn't really exist, or at least weren't used very often several years ago, and you'll see them pretty common in most parts of the country now, particularly in places and times of year where they didn't need to be in the past. There's also a separate website that is linked from National Weather Service and elsewhere called heat.gov. This is a screenshot from there from a few weeks ago. It just shows sort of the latest stuff posted. Some of these, when I took the links, we were still on the shutdown, so the sites hadn't been updated in a while. All the federal sites indicated, are they being updated or not? I didn't think to go get a new screenshot after this, everything's opened up. So just give you a sense of this is what's available. Some of you may have heard of heat domes, which is not, heat domes are not the same as heat waves or extreme heat, although they can be related and cause extreme heat. They're a separate meteorological phenomenon. And essentially, you get a high pressure system and a buildup of warm air with very low wind, and the high pressure system basically traps it and pushes it down. And when you compress air, even on an atmospheric scale, it warms up. It's called adiabatic warming. It means that you're increasing the temperature without adding heat to the system. If you're cooling something down without removing heat, it's called adiabatic cooling. And we see that with compressed gases. You may not think about it, but if you fill a bicycle tire really fast, compressing the heat, the tire will get warm. If there are any firefighters out there, we learn not to refill our air bottles too fast, or not to fill oxygen bottles too fast for EMS, because they can get really, really warm. Likewise, if you empty a compressed gas cylinder quickly, like canned air, and you're spraying it on your keyboard, you'll feel it get cold in your hand, maybe cold enough to start condensing some moisture from the atmosphere. That's adiabatic cooling driven by the rapid expansion of the gas. So you get the combination of warm air, a high pressure system that's keeping it in place, and then the fact that that high pressure is compressing the air a little bit, and that makes it even warmer. Another definition, heat island. You may have heard this term. It applies particularly to heavily developed urbanized areas. And it's really just an acknowledgement of the fact that heavily built areas tend to absorb and hold, and then at night radiate heat far more so than green spaces or less developed areas. That's a combination of the type of materials that we use, the fact we still have a lot of dark pavement and dark roofs, and just the fact that they are designed. Buildings are different than the natural environment. So you can see at the top, the orange line is the surface temperature during the day, and then the dotted orange line, dashed orange line going across, is the air temperature during the day. And in general, the air temperature doesn't change a whole lot with this effect during the day. At night, you can see both the surface and the air temperature increase around that downtown area because you are radiating a lot more heat outwards and you don't get anywhere near the same cooling effect. And you can get a difference of several degrees, 5, 8 degrees between a rural, even suburban area and a core downtown during hot weather. That's really significant, especially when we start to talk about who's at risk and how heat affects people. So, having gone this far, I'm going to toss one more uh, poll out for you. This one is similar to the last one I asked, but it is annual worldwide basis as opposed to a US. Same questions, just looking at the world as a whole versus the US in particular. Okay, 17, 18, 19. Can we get one more response? Nope. All right. So here's what people came up with. Most of you said pretty similar to the last question. And in fact, cold kills far more people than heat on a global basis. And that has been the case for pretty much ever. Um, Part of that is just the fact that we have a lot more space under the cold weather part of the temperature graph than we do under the warm weather. And part of it is where people live and what is considered to be an extreme environment and what they're susceptible to. And the only reason I put that up is not that, I mean, we are focusing on our neck of the woods in the US, but um, while we are narrowing the gap between cold and heat related deaths, and that's not necessarily a good thing, we're doing it because things are getting warmer. Historically, cold has been the primary environmental hazard that we have tried to mitigate wherever there are people or that individuals have tried to mitigate. So just thought I'd put that up as a little comparison. And apparently I surprised everybody. So we're going to take a look at each of these: built environment, natural systems, and people in terms of what extreme heat does. Starting with buildings, we know that particularly in areas that aren't used to extreme heat, buildings, if buildings weren't designed to be open, and most of them are designed to be sealed, you have what was built in. So if you don't have an HVAC system that can keep up with really hot weather, then you're going to have a problem. Or most buildings are not designed to do anything about the urban heat island effect, so they are contributing to that. They are also obviously consuming a great deal more energy to maintain a workable environment, whether they are, or for that matter, a livable environment. And depending on where you are in the country, in the warmer parts, central air conditioning is pretty common. In the northern part of the U.S., particularly areas like the Northwest, central air conditioning is far less common, and window units for AC are less common, or they're there they're there for like one room or something. So a lot of buildings aren't designed that way. And that link for the WAPO Washington Post article from a few years ago, our safety net and really our electrical utility, for the most part, were built to support heating in winters. That was what everything was built around. And you can't just flip a switch, literally or figuratively, to now magically change it for demand being at the opposite time of the year and for a different purpose. Heating systems and HVAC systems are different. They use different types of systems. They use different fuel. You're probably not in a lot of parts of the country. You have. I remember growing up, we would have home by home delivery of fuel oil in New England per hour furnace, and that changed to natural gas, and then some places went electric. You can't do the equivalent for AC. You basically need a window unit. So that's really significant. For transportation, think about all the different effects that hot air has. Any kind of paved surface, the hotter it gets hot enough, you start affecting the quality of the paving, the asphalt, and it can buckle, which means it will not do as well as far as supporting heavy weights, and local streets will see greater damage. Rail lines can warp, and if they are powered by electrical overhead, whether it's light rail or commuter rail, or even like the Northeast Corridor where you're going interstate, you may have sag in your electrical lines, and depending on whether you have independent source of power or part of a local utility, you may even have trouble maintaining power. In air, it's pretty simple. Hot air is less dense than cooler air, which means aircraft get less lift. And you may not notice that on your flight, but depending on where you're taking off from and how much hotter it is than normal, that may require weight restrictions so a plane can get airborne. And in the high altitude airports country like Denver, it's going to substantially limit what flights can carry. When I was in EMS in Texas, part of what we looked for in the helicopters that we had in our system was the ability to basically do their job when it was really hot. And when we went to a new version of helicopter and getting away from some of our enormous bells, I remember one of the selling points was this twin engine helicopter can hold a single engine hover at 4,000 feet on a 100-degree day. That's pretty darn impressive. So the hotter the air, the more potential impact you're going to have on what can fly or how much can fly, as well as potentially affecting the runway or the power demand for the airport as well. Um, Extremely hot weather always has a higher demand. Increases the demand on our electrical power transmission and distribution systems, just in terms of what we need to generate, but also high energy usage combined with high heat is going to make power lines sag. I don't know if y'all remember the big Midwest or Mideast, whatever you want to call it, the big power outage in 2003 that started in Ohio. That was really hot weather, and there was a heavy demand on the system, and the lines started to sag and sag and sag, and apparently they hadn't kept up with their vegetation control, and eventually it contacted a tree, and then you had these cascading outages. I remember seeing a slide, a picture the next year, and there was no more nuance in vegetation control. They just clear cut the whole area. But extreme weather puts a greater demand on and can potentially hamper transmission distribution systems due to line sag on top of demand. Thermal power generation is also a challenge, in that just in general, in that you are putting out more heat if you are relying on surface water to as a coolant. The heat of your influent, in other words, the temperature of the water that you're bringing into the plant, if it's already hot, it is going to be able to absorb less heat, which means you're going to need more water. And depending on where you are, most thermal power generation plants, or really any plant that uses local surface water for cooling, there are laws to prevent against heat pollution. So regardless of the temperature for your influent, you have a max allowable temperature on your effluent, what you're discharging. The warmer your influent gets, the less heat you can let it take off without, getting outside your boundary, to the point that even 10 years ago during extreme heat periods, there were plants and, non-utility factories that had to either curtail or completely shut down because the temperature of their influent cooling water was at or exceeding the allowable maximum temperature for effluent, which means you can't discharge anything. That's really important. So that's just not just thermal power generation, but anything that uses surface water for cooling. We don't see that as much in the Northwest, in part because we use far more hydropower than thermal generation. But any place that uses thermal power generation or has any large industrial process that uses large amounts of surface water for cooling, that's going to be an inherent limitation. And then natural systems. We'll deal with the humans separate from the rest of the animal kingdom, but it's an interesting paper that came out in Proceedings of the National Academy of Science earlier this year, saying that we may be seeing riverine heat waves, i.e., the surface water temperatures, may be becoming more common at a faster rate than atmospheric heat waves, which is kind of scary given what that means in the river. You know, the temperature of the water determines how much dissolved oxygen it can hold. And if it gets too warm, it's not going to be able to support the life that is in there. We've seen that for decades, if not centuries. You know, when you have a nice shaded cold water stream, it can hold a lot of oxygen and sustain cold water fish like trout or salmon or others. You cut down some trees, and which means you're letting more sun hit the water, and the water warms, and suddenly it can't either support the same volume of trout or it can't support trout at all. Same thing with salmon, same thing with other surface species. And those are just the big fish that we actually know about. It's true with everything that's living in the water there. So in general, the warmer the water, the less volume of life and less diversity of life probably means that the normal species there are going to start getting replaced by others that can handle the warmer water. We see that offshore as well in terms of what types of fish and other marine life we have in the traditional fishing grounds. Air quality is also an issue in that, and we're separating this from things like wildfires, et cetera, but heat can exacerbate a variety of health effects related to air pollution, as well as potentially enhancing formation of things like ozone. I know in Texas, when I was there, when we had really hot weather, there would be an advisory asking people not to fuel their vehicles during, basically like a 6 hour period of peak heat because you get more ozone generation from the vapors that escape during fueling. I've never seen that in Oregon, even though the same thing happens. We do have better vapor capture systems than we did 20 years ago. But you can also generate more pollution. You can also exacerbate the effects that poor air quality has on people who are already dealing with other health problems. In general, extreme heat is going to affect both the plant and animal life. It will limit what the endemic species can do. It may stunt their growth. It may kill them off, and it will probably make them more susceptible to pests, vermin, microbes, et cetera, infection that can weaken them. And it will also make the area more susceptible to potentially invasive species that can do much better in the climate. We see that across the plant and animal kingdoms, and we see it in sometimes we get stuff, maybe we get a longer growing season in some areas, but extreme heat as opposed to just a warmer climate typically is not really good for anything. But it can make things more amenable for the species that weren't there before. And then for heat in humans, this is a screenshot from the heat.gov page with the link in the QR code there, who is most at risk. I'm not going to go through each of these categories, but if you go to that page, each of these categories, that's a clickable link and it will bring up additional information. I'm going to go through a few of them in a little bit greater detail. I'm just not going to, touch on all 10 of these specifically. But if you look at the broad categories, it kind of falls into a few groups. There are the people who are either exercising or working outdoors, whether by choice or by necessity. And then there are the people with pre-existing medical conditions. And then there are other folks who have some type of limitation on how their body can handle heat. Either they have less ability to thermoregulate, taking some kind of medication that affects their ability to do that, or they're not as mobile, or they simply have no way to protect themselves from the environment. They have no way to mediate that. And then we also notice the pets and support pets and service animals in there as well. For us, the big question is how well your area is adapted to heat. If you're in an area that normally gets really hot weather or really hot and humid weather and really warm nights, then you're probably seeing less of a deviation than you normally would. But you're still probably seeing greater extremes than you have in the past. Southern California is used to hot weather. They weren't used to the kind of weather they were getting the last few years in the summer. Same thing with Texas. Our last full year in Austin, it hit 112 in Austin, which is the highest. That was a record that it's been equaled but never broken. And it was just it's like this ridiculous. It's not why we left, but it didn't hurt. I never thought we would exceed that temperature in Oregon. When the heat dome here, we broke 115 in Portland, and I know elsewhere in the state we were at like 117, just absolutely miserable. And it is just the adaptation is not just the people, how acclimated they are, but how are you fixed for climate control? How many buildings have AC? Um, how does your public transit have AC, or are you just relying on either forced air or open windows, but no air conditioning? Workplaces, public places, potential shelters, libraries, the places that we normally use. How well adapted are those? How much of an urban heat island effect do you find? And then you look at some of the particularly susceptible people like those that, from the last item, very young and very old, who simply, the very, very young folks have a greater surface area to body mass ratio than anyone else, which means they are going to be more at the mercy of their environment, and they are also not as capable of thermoregulating. Geriatric population tends to have a slower, basically non-optimal thermoregulation as well. Plus, they older people tend to be on more medications than younger people, and some of those medications can interfere with our body's ability to effectively thermoregulate. And there's a huge bunch of medication classes. When I teach stuff like this to paramedics and EMTs, which I do in Oregon, I get into that detail of specific disease processes and medications, and that's just not what I'm trying to do for this audience. But if you're interested in it, you can follow some of the links that I'll share, or you can just drop me a line if you want. Same thing with pregnancy. There are a whole bunch of physiological changes, and heat is just one of several. But there's a ton of medications. Some particular medications, any medication, antihistamines are one. Anything that dries you out, that basically stimulates your adrenal glands. Some antipsychotic medications, any kind of diuretic that you might take to control high blood pressure or congestive heart failure is going to do that. And those are just a few. Also, people who've had severe burns, because scar tissue doesn't sweat. So if you've had burns over, like third-degree burns, skin grafts over, say, 15, 20% of body surface area, one of the things that those patients will be informed is you may not have been uncommonly susceptible to extreme heat before, but you are now. So you have to keep that in mind. You just lost substantial part of your ability to your body's ability to naturally cool itself. Anybody who's socially isolated, and this doesn't necessarily mean people who are poor or who are ill or anything else. It could just be people who live alone by choice, or who are extremely well off and live alone. But those without anyone to check on them are generally automatically at risk for more maladies, and those who do not have a lot of resources may be trying to, say, save money on heat or not have a well-functioning system, or if something doesn't work, hey, the HVAC isn't working or something else isn't working, you just have to hope that someone's available to fix it. And if not, there's no one to check up on. Yeah, that can be a problem. In general, you can see the categories there: those who are unhoused, poor, minorities, kind of the people who are more at risk for just about anything. This is magnified by any kind of exposure to urban heat islands. And access to cooling shelters was identified as a particular item related to risk several years ago, and it is now, for anyone doing planning for extreme heat, particularly for an urban area, that's one of the things that we try to work on. Where are the shelters? Are they accessible? And how many of them have to be for overnight, which is never something we never had to do before. Just not being able to afford AC or electricity use, even if you're guaranteed not to have your power cut off during a heat wave, not being able to afford any kind of modifications to a home to make it more, easier to deal with heat, that's going to be part of the risk as well. And then here are just a few things for specific aspects. Um, Several papers talking about not just the effect of heat on cardiovascular deaths, already a leading cause of death, but the fact that they could rise by 2 to 5 times by 2060 based on, depending on whom you're looking at and which climate scenario you're using. So, I mean, again, there are a lot of papers. This seems to be pretty well determined, and there's a pretty big error bars, but pretty likely trend. And then there's the effect on kidneys. So what this says is for every 1 degree Celsius increase in temperature, you get about a 1% increase in kidney-related illness and impairment, and about a 3% increase in kidney related mortality. And that's for a variety of reasons, but that's pretty significant because that's also a pretty common source of death and illness. And then fans. I remember when we were doing trying to do some mitigation for heat in Austin, the city was doing fan drives, donate fans, and they'd be delivered. And after, I think it was the first time this really came up was in the 80s, there was a horrific heat wave in Chicago. Hundreds of people died. And a substantial part of the population had no access to AC, but they were given fans and learned that, they sat in an apartment, and rather than using them to exhaust hot air, they just set the fans right on them, and they were basically blowing hot, dry, or in some cases hot and humid air on them. When we do that deliberately, we call that a convection oven, and that probably contributed to a lot of deaths. There is a lot of uncertainty, sorry, inconsistency, but pretty solid agreement that once you get to really high temps, so 95 to 140 degrees, that's 35 to 40 degrees Celsius, particularly with higher humidity. The longer you use a fan, the more rapidly your returns will diminish, and they may actually be harmful. You may be just exacerbating people's heating and discomfort. In any event, it's a poor substitute for AC. So fans can help, but at lower temperatures, but the hotter and particularly the higher humidity it gets, the more of a problem you're going to have. And then there's workplaces. This is the last one I'll point to as far as specific effects on humans before I wrap up a few other items. A lot of this depends on what kind of workplace we're talking about. Indoor, outdoor, warehouses, climate controlled. There are a range of presentation protections in place. The Network for Public Health Law, NPHL, has just put out a summary of what kind of workplace protections are in place. OSHA includes this, and we all know that right now OSHA is probably not working at its best, but there are really only a handful of states, the ones listed there, that have specific protections for workers in hot weather, and 2 states to date have actively limited the protections that states can enforce. There are medical policy recommendations. New England Journal of Medicine has put out some medical policy recommendations. These are just a couple of quotes from some of the papers that specifically looked at workplace exposure. That heat exposure doesn't just make people hot; it increases the overall risk of work injury. So it's not just heat related illness and injury. It increases bad things, likelihood of bad things across the board. And then this from the Urban Institute, where one of our NPTC instructors actually works, although he didn't work on this, Andy Rumbach. More than 1 in 7 outdoor workers. So I mean, that's 2023. That is a lot. And without protections, you basically you have folks who are kind of a captive audience and don't really have they tend to be afraid to complain. So they're among the most vulnerable things like this. This is from some really handy stats, and some of this was I saw this presented from one of our warning meteorologists, Trina Jensen, in the Portland Weather Service office. But just a broad trend from 1874 to 2022, seeing, you probably expected the graph on the top, but the one on the bottom is really important. Far more nights where it doesn't get below 60. In 1980, that was 20 days. In the last 10 years, it was almost 50 days, and that trend is continuing. And it's the warm nights that really make a difference. When I was working EMS, we could always tell when really bad heat was setting in because we'd be running heat calls in the morning, and hospital emergency rooms were getting heat patients in the morning, and it was it was a really strong sign that, yep, it is setting in, and people who can't cool off were getting in real trouble. For the Northwest in particular, this one is relevant because it shows that for hydropower generation, which is what we mostly rely on in the Pacific Northwest, um, the annual cooling degree days are increasing, and the hydropower generation is probably peaked and may even be decreasing. So you don't want those lines to cross, especially with the generation line now going below the demand line. And yet that's the trend that we have been seeing so far. That's not a good sign, particularly given the challenges that we know extreme heat puts on our power system. These informations are from these graphs are the information from the HAZStat site. You can go there now looking at weather fatalities by nation, by state, by cause. And I want you to pay close attention to the vertical graphs on these. So the 2019 graph on the left shows all the different types of natural hazards that they look at. The yellow bar, the tallest under the heat one, is a 30-year average. Then the blue bar in the middle, basically the right-hand one is 30-year average. The middle bar, which is light blue, is 10-year average, and the red bar, the one on the left for all the hazards, is weather fatalities for whatever years at the top. In this case, 2019. So you can see heat, not a great year, but the vertical scale tops out at 140 over there. Now go to 2024, and you can see that first of all, we got 100 more. The 30-year average has gone from 138 to 238. The 10-year average has gone from 103 to 199, so almost doubled. And the total stats, total fatalities, 2024 are almost 3 times what it was in 2019. The vertical scale instead of 140 is 250, which is why the graphs don't look that different for heat. And the reason for this isn't just the really bad heat dome in 2021. You look at the stats for 2021, 2022, 2023, and they're all highly elevated. But if you look at 21, when we had the heat dome park itself over the Pacific Northwest, and we killed probably somewhere between 600 and 1,000 people between Washington and Oregon, and that doesn't even include the deaths in British Columbia. You can see the vertical scale now tops out at 400, and 150 is way, way down below the middle. 375 attributed deaths, and that's when we really started to tweak the 10 and 30-year average in a big way. And remember that it's really hard to attribute morbidity and particularly mortality, sickness and death, to heat or to cold. So these are almost always undercounts. Oregon was in the top 3 that year, which is not really a place that we want to be. This is also from NCA 5. This is looking at heat-related emergency room visits in Region 10 for Health and Human Services, which is the same federal region as we use for FEMA. And you look at that spike for the heat dome event in 2021 and just how much that was off the growing trend, even though it is still a very much a growing trend. For those of you who've been to my presentations or my classes, you know that I generally disdain the term lessons learned because they almost never are. But I want to point to something that happens. This is our convention center in Oregon. As far as I know, the first time we ever used it as a overnight heat shelter, and I think it is the first time that we ever needed to do overnight shelters for hot weather ever in the metro area. And there are an awful lot of people in there during the heat dome in 21. I mentioned how many people died. A few years later, when we had not a heat dome, but a really substantial heat wave in July last year, we actually did learn. There have been a lot of revisions to existing plans, a lot of changes to how we sheltered people, but also our state Department of Human Services and our state public health agency, Oregon Health Authority, worked together to go through their case files and their case managers and identify hundreds of potentially vulnerable people who could benefit from having portable AC, easy setup AC that would be delivered. And we delivered over 500 of them. I was part of they eventually realized after a day that they wanted to have a medical provider on each team to assess people to make sure that all they needed was an AC. So I and several other our state medical volunteers filled that role, but we delivered over 500 of these suckers. And outside of the Portland metro area where they didn't have the same manpower, The state actually is authorized to contract with, I think it was FedEx. It may have been more than one delivery service to actually do direct delivery. And the fact that they were willing to do that was, the fact that our state was willing to do that was astonishing. But sometimes we actually do learn real live lessons. Um, and I just wanted to point out that while this affects everyone, it really affects our healthcare system, whether it's hospitals or EMS. Working out there is absolutely miserable. I mean, it's bad enough fighting fire and turnout gear, but we run a lot more medical calls when we fight fires. And for anyone who has to just keep going out there, and particularly if you're wearing any kind of PPE, ballistic vest, which we had even in the 90s, hazmat gear, law enforcement officers wearing that, it is just exacts an enormous effect, as well as all the secondary and tertiary effects that it has on our infrastructure from what's going on with, say, our electrical and transportation system. Um, these are perfect targets for mitigation as well as adaptation. In other words, can we change the way some of our healthcare systems work so that they are dealing with direct cause as well as simply adapting? But that's for another time. I will, as soon as I close out the slides, I'll drop the link to all of these sites. But all the different extreme heat portals and playbooks, HUD, EPA, CDC, a few examples from the states, a few examples from the Portland metro region with their mapping campaign. And if you have any, if you want to, I'm always happy to correspond if anyone wants to drop me a line or continue a conversation at another point. I am always happy to do that. I will stop my screen share and see if we got questions. Hey, I forgot, Amy, I forgot I sent those to you. Thank you for dropping them in the chat. You are welcome to use those. Any questions, comments, even better, disagreements? I have stunned everyone into silence. Either that or they were just all napping because it's the afternoon. Okay, Sarah, have at it. You can unmute and toss it out.
Aloha, I'm from the Kauai Emergency Management Agency. I'll turn my camera on, sorry. So that you can see me. Bye. So we're currently updating our multi-hazard mitigation and resilience plan. And so heat is one of the topics that we're bringing up. And we're looking for like a local subject matter expert. Some of the references that you have don't like one of them with like mapping specifically doesn't include like continental US, or it only has continental US. And so I was wondering if you had a Hawaii counterpart that we could maybe reach out to.
The top of my head, no. Someone in NDPTC may know folks who are working in there. I would say, you might want to start with your Weather Service forecast office.
Mm.
They are certainly experts. Whether it's at Manoa or Hilo may have uh, folks who are working in that area, in terms of atmospheric or oceanic sciences.
Mhm.
And you could also follow the link to the what Portland did for assessing heat and heat vulnerability and mapping that out in their area, because that was just a local project that they did. That was not part of a broader national system. There's no reason that y'all couldn't do that locally.
Perfect. Thank you.
Anybody else?
Thanks for your question, Sarah. Yeah, it says if you could possibly drop your email into the chat. There you go. Right on. I think we have time for one short question. Yeah, Michael,
Michael.
if you want to go ahead.
Yeah, thanks for presenting, Jeff. I oversee a county level public health, climate and health adaptation plan, and a definitely something that I'm trying to do with a lot of community partners that I've worked with is to bring in different grant funds and resources in order to actually do the work that we want to do. And so, do you know if there's like specific grant opportunities other than just pointing to grants.gov, because a lot of those that were on there federally aren't specific to climate work, where, you know,
I have no idea. And anything at the federal level, who knows? Maybe foundations, but I'm not aware of anything in particular. We got time for Marie's question?
Yeah, I just wanted to really check Sarah, make sure I got her. I'm from Oahu and kind of in the same boat, although I don't think anybody I don't think anybody else is here from Hawaii. And this is an issue, particularly with our kupuna. And when you spoke about humidity, it was like, hello, hello. Um, so that information, Sarah, that you're putting in the chat, I'd like to hook up with you. I'll give you mine too, okay? Mahalo. Okay.
Thank you.
You're welcome.
Be
Thank
curious
you
to
for
see-
this too, Deb. Thank you. Thank you very
My
much.
pleasure. I'd be curious to hear how that turns out, Sarah Bree, because I mean, I'd be shocked if you didn't have local expertise. I just don't know where to point you. But Weather Service is a good place to start.
So if anybody has any more questions or comments, please reach out to Jeff. He put his email in the chat. If not, then you can go ahead and reach out to us at NDPTC as well. But with that being said, we just wanted to mahalo everyone for joining us today. We hope you found this session on extreme heat very insightful and useful for your work or your community preparedness efforts. Really quickly, before we close, I just wanted to mention that our executive director, Carl, couldn't be here. He's serving on several master's capstone and thesis defenses for the Department of Urban and Regional Planning today. So he couldn't make it, but he did want to
I
extend
am
his
deeply
thanks
hurt.
to all of you folks for attending. And yeah, just thank you all for always coming to our Third Thursday series if you folks have been, and welcome if this is your first time. But yeah, just a quick reminder, a few people were asking, today's webinar was recorded and the full session will be uploaded to our NDPTC YouTube channel and the Facebook page. So we'll be sending out a follow-up email that includes the recording along with any resources, PDFs, or materials that were shared. And just really quickly, we also wanted to highlight that the Primo Pacific Risk Management Ohana 2026 conference will be taking place on March 16th to the 18th in the year 2026 at the University of Hawaii at Manoa. So the registration information and the links should be dropped in the chat. Yeah, thank you, Amy. And yes, we just mahalo you folks again for spending the afternoon with us, and we look forward to seeing you at our next Third Thursday webinar event. So have a wonderful day, everyone.
We hope.
Ahui ho.